Okay, so let's welcome back to my class. So let's continue from where we stop. So we are asked to draw the following structure. We have done the first one and the second one. So let's look at the third one. 2,3,4 trichlorocyclobutane. So let's draw the structure of 2,3,4 trichlorocyclobutane. So let's see. What's the first thing? Cyclobutane. This is the family of the cyclo means cyclic, like circular parts. Cycloalkane, like I told you before. This is the homologous series. So the family is the alkane. You understand me now? So let's see. Cyclobutane. Now I say but is 4. So which means let's look at it. 1, 2, you can see 3, then 4. You do it like the form of cyclic. So let me clean this one. I don't disturb us. Let me clean this. So let's see. So each carbon atom we have 2 bonds. You understand now? 2 bonds to fix. 2 bonds. You can see 2 bonds. Just like a straight chain. You know, for a straight chain we have two bonds up and down, up and down. So same thing here. 2 bonds, 2 bonds. So you can start with 1 from here. 1. You can say 1, 2, 3, 4. Or go to the back. 1, 2, 3, 4. So cyclobutane. You know, each of them we have a HH. So let's see. So that's for cyclobutane. Now, 2, 3, 4. Chloro is the branch coming in. Chloro, that's chlorine. So chloro will be in carbon number 2, carbon number 3, and carbon number 4. The tri means 3. 1, 2, 3. That's where the tri comes from. Let's put chloro in carbon number 2. So this carbon number 1, carbon number 2, you can put chloro anywhere, up or down. For here also, you can put it anywhere, this or this. You can put it anywhere, this or this. So 1, 2, chloro is number 2, number 3, and 4. And then you put the main one for H. Put your H in your rest, HH. Put your H, put your H, and put your H. So this is 2, 3, 4 trichlorocyclobutane. You can see, very simple and easy. So having known that, let's look at the next one. So the next one is what? The next one is what? Let's look at it. Say that trans 1,2-dichloroethene. Trans 1,2-dichloroethene. Ethene is the parent name from the family of the alkene. And don't forget that the alkene have the structure CnH2n. That's the alkene family. So don't forget that. So an ethene is number 2. So that's N is 2. C2, H what? 2 times 2 is 4. So 1, 2. You can see. Don't forget that the ending, this is C2, C1, C2. So the ending must be filled with H and H. So that's 2H, 1, 2, out of the 4. So now, alkene. Alkene has a double bond, double. You can put a double bond, you are going to put the double bond between the C and C. The C and C, you can see double bond. Understand me now? So for a double bond, you have to fill one, leave one. Fill one, leave one. You understand me now? Because carbon can take the maximum of 4 bonds. You understand me now? Don't forget that. So let's see. So this is the structure of ethene. C2, 1, 2, C2. Then H4, 1, 2, remain 2 more H. So we can put the H here or here. Let me put it here. You can put the H here or here. And put it here. That's where the trans comes from. Trans 1, 2. Trans means say trans 1, 2 dichloro. Dichloro. Chloro is chlorine. Di means it's come in 2 places. Dichloro. So 1, 2. That's carbon number 1 and carbon number 2. Carbon number 1, put my chloro there. Chloro. Carbon number 2, put my chloro there. So 1, 2, 1, 2, 1 and 2. So trans means 1 up and 1 down. Trans. So trans 1, 2 dichloro. Then these are ethene. Then we also have one as cis. If it's cis, that means the chlorine will be in the same place, ClCl or ClCl. You can see. So that's the structure. Note that. Thank you for that. So now let's look at the next one after that. So the next one is what? Is that's propan 1, 2, 3 triol. Propan 1, 2. So that's the structure of alkanol. Because of that that all is OH though. So the general formula is ROH. Just like the one we did in my previous class, that's for alkanoic acid. So this is ROH. And don't forget that I said my R is what? CnH2n plus 1. The alkyl group. Don't forget that alkyl group. You understand the alkyl group? So let's see. So propan, that's 3. So that's C3, Cn is 3. H what? 2 times 3 is 6. 6 plus 1 is 7. Put your OH. So this is R, then OH. So let's do that. C1, C2, C3. Don't forget that. Up and down, up and down. Then the OH. You can see. But here they say propan 1, 2, 3 trihol. The OH is tri. That means the OH is coming in 3 places. So OH is coming in carbon number 1, carbon number 2, and carbon number 3. So I can just put the OH here. Carbon number 1, number 2 also OH, carbon number 3 OH, so trihol, or, and all. If I start from the back, you can also start from the front. So from the back, 1, 2, 3. Then the rest will be our H, normal H. So we have H, 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 and H. So this is propan. 1, 2, 3 is propan. 9, 1, 2, 3 trihol. That's that. You can see very simple. So I can also write it this way. CH2OH, CH1H2, H2OH. The next one is CHOH. You can see, you can do like this, CHOH. Then CH2 also OH. Then another CH2, you can see OH. We have CH2OH here. Then CHOH here. Then another CH2OH. So CH1H2OH is there. Then CH1OH. Then CH1H2OA. You can see. So that's the structure. So the last one is what? Propyl butanoate. Propyl butanoate. So let's see. Let me stop here for now. So I will continue later. Don't forget to subscribe to my YouTube channel to get more. Thank you.